Welcome back. In this video I'm solving Leetcode 918 maximum sum circular subarray. Given a circular integer array nums of length 10, return the maximum possible sum of a non-empty subarray of nums. A circular array means the end of the array connects to the beginning of the array. Formally, the next element of nums of I is nums I plus 1 modulo n. Okay, so we can use it most. Well, in this type of problem, we need to use Codaine's algorithm, but since, let's maybe see, okay, this would be a good example. So we can have two types of solution. One solution that is going through the original array, and one solution that is circling around like here, so from 5 till 5. And 10 is actually the answer here. And how can we calculate this? So if we have a solution this way, we can do just regular Codaine's algorithm. So 1 minus 2, so 1 is currently best, minus 2, that's minus 1, so we do not care about this. 3 is the best, 3 is the best. But if we do this way here, we'll have 5 is the best, 5 minus 3, okay, current is 2, and plus 5, that's 7, and I will have 7. But there is a neat trick that we can do to fix the problem of not finding the circular array. So, and that's something that that kind of, if you know, you know. But essentially, if you're looking for minimum sum subarray, if you take minimum sum subarray minus total, you'll get an example here. It's minus 3. So, and total is 7. So 7 minus 3, we get 10. So if you take minimum subarray, then minimum sum subarray, then you can get the wraparound thing. So yeah. But we kind of have to be careful, because in case that we have all negative numbers, so that's minus 8, so we don't want to take total minus minimum sum subarray and present that as a potential solution. So it has to at least have one element. That's what I'm trying to say. So sum maximum subarray going through has to be greater than 0, because if it's not, then all the elements are considered. So let's try to code this up. So I'll have total, which is equal 0, current min sum, which is equal to nums of 0, current max sum, which is equal nums of 0. So min sum is nums of 0. Everything is nums of zeros here, so max sum is nums of 0. Okay. So take this from 1 on. So total is just increased by n. Current max sum is equal max of current max sum plus n or n. Mean of current min sum plus n and n. And now I have to update min sum is equal from min of, I'm not sure why did I do this. So min sum is min of min sum current min sum, max here, max sum is equal max of current max sum max sum. And that's essentially it. So what do we have? So best is equal max of max sum or total minus min sum but we want to consider this one if max sum is greater than 0, else max sum, something like this. Yeah, and we need to return, we can just return here. Okay, looks good and it works. So yeah, kind of, if you know it, you know it, but possibly you can come up to this solution. You just have to be, you just have to have understanding of Cadane's algorithm and understand this wrapping around how it's done. So essentially, min sum is exactly opposite of total minus min sum is wraparound max sum. So, but we only consider that if max sum is, if we have that solution, so it's wrapping around and it's bigger, but max sum has to be greater than 0, because if it's not, then all the numbers are in min sum. And yeah. Okay, let's check complexity. So time complexity is just off, and we go through all of them, and of one we have just few variables. So let's confirm. Okay, hope this was clear. If you have any questions, leave them in comments, and I'll see you in the next video.